So let's start with sec. Let's start with sec. No, what is sec? Sec is 1 over
cos.
1 over
Cos.
1 over cos. Okay. So let's say we have sec here. Sec theta is equals to 1 over cos. So in fact, what we are simply going to do here, we are just going to sketch a graph of cos. Let's say from 0 to 360. We are going to take our sketches from 0 to 360. So let's start from 0 to 360. Then faintly you can sketch the graph of cos. We are simply saying we obtain the graph of sec from 1 over cos, isn't it?
Yes.
Okay. So I'm going to sketch the graph of cos. I'm going to sketch the graph of cos. So here I want sec. Here I want sec theta. Here it's where I have my theta. And what's the maximum function for cos? The maximum function is what? It's 1, right?
Yes.
The maximum. Then I put my maximum here. I have to put my maximum here. I have my 1 here, and here I've got my 0, and here I would have my minus 1 here. Then I will take the ranges 90 degrees, 180, uh, 270, 360. Okay. Or whether if you want to expand, what's the next value after 360? If you add plus 90, 360 plus 90, what do you get?
It's 450.
What?
450.
450. Something like that. Something like. Okay. Then we want to sketch the graph of cos. No, the graph of cos starts at what? It starts at 1, isn't it?
Yes.
We want the graph of sec, but we are sketching the graph of cos firstly, faint, then, or maybe in dotted lines, or let me use different colors. Let me use blue here. I'm using the blue one. So here, something like this. You do physics, right? It's a wave. Something like this. Isn't this one is the graph for what? For cos. Yes.
Yes.
So if you want to find the value or the graph for sec, we are saying sec is 1 over cos, and 1 over 0. If you divide everything by 0, you get an error. So we are going to have asymptotes where the graph cuts 0, where the graph of cos cuts at 0. Like here, we are going to have an asymptote here. We are going to have an asymptote where the graph of cos cuts 0. The graph of sec won't passes through that. Like here, this one will be our This will be our it will be our asymptote here. It will be our asymptote here. Right, we said where the graph of cos cuts 0, the graph of sec won't exist there, because we don't have the value, or we don't have the value of sec when cos is 0. Because if you take a calculator and if we punch 1/0, you're going to get what? Error. So firstly, if you draw the graph of cos, then you are going to see where the graph of cos cuts the x-axis. It cuts the x-axis at 90, 270 and 450. So the graph of sec won't exist there, because the value of cos will be 0, and 1/0, the graph doesn't exist there. Are we together?
Yes.
Right. So now let's sketch the graph for let's sketch the graph. Now let's sketch the graph. So it will oppose, let's start with this region. In this region from 270 to 450, our graph is taking a maximum, right? Isn't it?
Yes.
Then the graph of sec will oppose that maximum. So it will be reflected at what? At 1. So it will be something like this here. Right?
Yes.
And here it will be like a minimum. It will be a maximum. Here. Then here you have a graph like this, isn't it?
Yes.
So that green graph is the graph for what? For sec theta. Are you also drawing?
Yes.
Oh, okay. So we are simply saying in the exam, if you want to draw the graph of sec, maybe if you forgot, you have to first of all sketch your graph of cos. But you have to sketch it very faint, or maybe if it is faint, then you rub it afterwards. It's okay. But just, or maybe from your imagination, you would know your graph of cos. Then from that, you know where you are going to obtain your asymptotes. We are going to obtain our asymptotes where our graph is going to cut the x-axis, like at 90, 270 and at 450. Then you have your asymptotes. Then the graph for the inverse will be in piecewise. The region where the graph of cos is maximum, the sec will take the minimum. The region where the graph of cos is the minimum, your graph of sec is going to take your maximum. Clear?
Yes.
Oh, okay, fine. So I want you to sketch the graph of, I want you to try this one, the graph of cosec. Can you do the graph of cosec? I'm giving you 5 minutes, at least 5 minutes. The graph of cosec theta is the same concept. Cosec is 1/, what?
Sine.
1/, sine. So we are going to sketch the graph of what?
Sine.
We are going to sketch the graph of sine. So let me give you 5 minutes. 5 minutes. In this case, can you try to use minus 360 to 360? Minus 360 degrees to 360 degrees. Rutendo. Can you try to sketch your graph from minus 360 to 360 degrees?
Okay.
Okay. Right. Like what we have indicated earlier, as you can see, right, we sketched the graph of cos, and our graph of cos was maximum at 1 and minimum at minus 1, as you can see. So the graph of sec will start at 1 moving upwards. You know, this one, it will be turning at what? At 1, isn't it?
Yes.
So you were supposed to obtain a graph like this. You were supposed to obtain a graph like this. This one is the graph of cosec. The blue one is the graph of sine, right?
Yes.
The graph of sine is maximum at 1 and minimum at minus 1. Yes?
Yes.
And the asymptotes, yes, your asymptotes were very correct. But like in this region from 0 to 1,8, it was supposed to be minimum at 1, not some. Yours is maximum. It's like maximum. It's opposing. Like the graph of in this region, if you can look at this region from 0 to 1,8, our graph of sine is maximum. So your graph of cos will be minimum, turning at 1. It will oppose. Yes?
Yes.
Then from 180 to 360, the graph of sine is minimum towards minus 1. So our graph of cosec will be maximum towards 1. It will turn at minus 1. Right?
Yes.
Then here from 0 to 180, our graph is minimum for sine, minimum at minus 1. Then the graph of cosec will be maximum at minus 1 and not touching these asymptotes. These broken lines, they are asymptotes. The graph doesn't cut there. Same applies from minus 180 to what? To 360. Yes?
Yes.
Okay, so you can let me take a screenshot and let me send you, then you correct it. Let me take a screenshot. Okay, I have sent you the screenshot. Okay, back to our question. We were required to sketch the graph for, is the graph of chord, right, within this interval. Like we are going to sketch. Okay, firstly let's sketch the graph of chord from, let's sketch the graph of chord. Here it's the graph of chord from, I'm taking it from 0 to 2 pi, because here it's in terms of radians. You know pi is 180, right?
Yes.
Here it's cot. Have you done transformations under functions?
Yes.
Oh, okay. Generally, I want to sketch the graph of cot. Here it's 90. Oh, sorry, I want to use in terms of radians. 90, it's pi over 2, right?
Yes.
Then 180, it's pi. Then the other one is 3 over 2 pi. Then we will have 2 pi. So it opposes the graph of tan. The graph of tan passes through what? The graph of tan, it passes through 0. The graph of tan passes through 0. So 0 will be our asymptote here. And also the graph of tan passes at 180. And our 180 is going to be asymptote. And also 2 pi is going to be our asymptote for the graph of cot. So it will take this direction. To be like this. Here it will be like this. This one is the graph of cot. Yes?
Yes.
Okay, let me take a screenshot then send you. This is the graph of cot. This one is the graph of cot. Okay, now back to the question. We want to sketch the graph of cot half x. Cot half x. Cot half x. This one is transformation in the x-axis with the stretch factor of 2. We're going to multiply all the terms of x with 2. Okay, we will look at transformations together, but we are saying if you want to sketch this graph of cot half x, this one is a stretch. This it represents a stretch of cot x, right?
Yes.
Whereby we are going to multiply with the stretch factor of 2, where we are going to multiply each and every coordinate of x with what? With 2, right?
Yes.
So meaning to say, if the graph of cot was passing at pi over 2, if you multiply pi over 2 by 2, it will pass at what?
Pi.
It will pass at pi. And we are going to remove this, and we will be removing this asymptote. Ish. It's not wrapping, okay? I'm now removing this asymptote. And where is the asymptote? This asymptote going to? Because we are going to multiply pi by 2, and this asymptote is going to shift to what? To 2 pi, right?
Yes.
Oh, why am I not? Okay, fine. So this asymptote is going to shift to be at 2 pi, and this graph is going to it is going to cut at what? at pi, because we have multiplied everything by 2 because it's a stretch. Let me use another. And 0 if you multiply 0 by 2, it will remain as it is. So this asymptote is going to be a 0. So it will be a graph like this. Sorry. Okay. That will be the graph of quarter half x. I've removed this one. Right?
Yes.
Yes. So this one is the graph of quarter half x from 0 to 2 pi. But as you can see from the question, they are saying from the interval 0 to what, to pi, right?
Yes.
So we are going to remove the, or we are going to remove this part. Wow, what happened? Okay, we are only going to sketch up to this point, so it will be something like this. Yes, it's a curve, it's not a line. So next we want to sketch the graph of, the graph of e to the power of minus x.
Yes.
Then we are going to shift it with the 1 unit upwards, because this one is a translation of graph of e to the power of minus x with 1 unit upwards. So we are going to shift it. Originally the graph of e to the power of minus x cuts at what, at 1, right? So if we say 1 plus 1, it will cut at what, at 2. And it will take, because originally it will be here, this one will be the graph of 1 plus e to the power of minus x, right?
Yes.
So it will be like this one, but it will be cutting at 2 because of this 1 plus 1. I think you have tried, but you were supposed to clearly indicate the intercepts, like 2. To indicate 2 was very, very necessary. So as you can see, what will be your comment? The graphs intersect what, once, right?
Yes.
Then it will imply that we have sketched, by sketching a suitable pair of graph, we have shown that the graphs, that equation is exactly one root, because it cuts once here. So I think you are now able to sketch the inverse functions for trig, cot, cosec, sec, and what? We said cot, cosec, and sec, right?
Yes.
Okay, fine. Then B, your B was correct, right? There was change of
Yes.
sign for the function. You have indicated your function. Okay, correct. I'm marking it now. And also there was a change of sign. Then also this iteration is the last peak that you have sent, right? Starting,
Yes.
you have started with x1 equals to what? 1.25.
Yes.
Where are you getting 1.25?
Um.
Oh, okay, between 1 and what? And 1.5. Okay, fine. We said it will be our appropriate first approximation. Then you iterate it to what? To 1.34. Okay, so C In each case, you are giving it to 4 decimal places, right?
Yes.